All right, let's do some problems where we're just solving the equation and listing the answers that are on the interval from 0 to 2 pi. We're going to split this into two parts. One where there's no coefficient on theta, and then after that we're going to do it where we have a coefficient on theta. Now, these first few examples are really very similar to what we did in the previous video, so I'm going to go through them a little quickly. On this example, it says find all the solutions to this equation on the interval from 0 to 2 pi. All right, so I'm going to isolate this sign. I get sine theta is minus root 2 over 2. And I know right off, that means my reference angle. You have to think which angle has a sine of root 2 over 2. And for now, ignore the negative. So you ignore the sign, the plus or minus, when you're trying to figure out the reference angle. So our reference angle is pi over 4. Then we look at a simple trig chart, and we're trying to figure out where is sine negative. Well, sine's negative here and here. So I'm going to draw my reference angle in down here and here. This is going to be, my reference angle is pi over 4. This one here is going to be 5 pi over 4. And this one over here is going to be 7 pi over 4. Okay, how do you get 7 pi over 4? Well, you can count around. You can count around and say this is 0, 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7 pi over 4. Another way you could do it is you could say this is a full revolution is 2 pi. And you could do 2 pi minus pi over 4, and that would also give you this. And since this is just solving, it's just asking for the solutions on 0 to 2 pi, we don't want to add the 2 pi in on this. No need to. Okay, here's a tangent. Tan theta is 1 over root 3. All right, so let's see. I'm cheating with my calculator. The tan of 30 degrees is this. So my answer is, our reference angle is 30 degrees, but we got to put it in radians. So that's pi over 6. Then we look at a simple trig chart. We're interested in where tangent is positive. So that's going to be this quadrant here and this quadrant here. All right, so we're going to draw a reference angle into both of those quadrants. So pi over 6 up here. And if I draw it into this quadrant down here, this gives me 7 pi over 6. And those are my two solutions. How to get that 7 pi over 6? Well, this is pi. So that's 6 pi over 6 to get around here, and then 1 more pi over 6 to get down there. All right, example 212. Notice the only difference between this one and example 211 is this negative right here. So in this case, we've got the same reference angle. Reference angle here is still pi over 6. But since we're looking at this being negative, we want to put this reference angle into the quadrants where tangent is negative. So that's in quadrants 2 and 4. So if I put it into quadrant 2, I'm going to draw this bigger. If I put it into quadrant 2, this angle is pi over 6. And in quadrant 4, this is pi over 6. So this up here is going to be 5 pi over 6. And this is going to be 11 pi over 6. Because it's pi over 6 shy of 2 pi. So pi over 6 shy of 12 pi over 6. So my solutions are 5 pi over 6 and 11 pi over 6. Notice on the tangent, the something interesting happens. These two, they line up. The two reference angles that we picked, they line up and make a straight line. Same thing here. That doesn't happen on the sine and cosine problems. Like sine and cosine, the reference angle, when we put them there, they meet at an angle instead of shooting straight through. We'll see the significance of that in another video or two. Okay, let's look at this last. This is the last example for this video. Solve this equation on the interval. Okay, well we've got 7 cosine theta and negative 2 cosine theta over there. So we need to combine these to make them, put them all on one side. I think what I want to do is leave the 9 over here. And so let's subtract 7 cosine theta off of both sides. All right, when we do that, this side just becomes 9. This side is minus 9 cosine theta. So we get cosine theta is negative 1. All right, so since we've got negative 1 here, instead of looking at a reference angle, let's look at either the unit circle or the either the unit circle or the graph of cosine. Whichever way you feel better, go with it. All right, so on the unit circle, remember the coordinates are cosine theta, sine theta. So cosine is the x-coordinate, so we're looking for where's the x-coordinate negative 1. Well, let's see, x-coordinate is negative 1, let's see, over here. So this is my solution here at pi. Now, if we look at the graph, we say where is this graph? Where is its y-coordinate equal to negative 1? Well, that's right here, and that's also at pi. So you can think of this in either way, and both ways get you an answer of pi. All right. So the next thing I want to look at is what happens when you have a coefficient on your theta. We'll look at that in the next video.